So in this part of the lab, we are going to take a look at gas emission tubes, and we're going to look at them through essentially a prism, a diffraction gradient that will split the colors into a potential rainbow. So remember, we talked about the fact that if you have a continuous spectrum, you see a rainbow. But elements don't produce a continuous spectrum. Elements produce a discontinuous spectrum, which means they don't produce all the colors of the rainbow. So that's why the flame test produced a color instead of just white, because the elements can only produce a certain color. So what we're gonna do is we're gonna take a look at white light, and then we'll take a look at some gas tubes through our diffraction gradient. And if you were in class, and I'm sorry that you're not, you would get to put them on. They are pretty cool. They look like 3D glasses, but they're not. They are a prism type glass. They split the light into a rainbow. So if I were to put this over top of the lens, oops, you can't see because I have to turn the camera around to do that. I'll do it in a moment. But you will be able, if we were to look at the light or the sky or whatever, you'd be able to see the various colors of the rainbow. So let me get the phone set up and the equipment set up, and I will show you what I mean. So again, if all of you were in here with me, I would have made the room very, very dark, but unfortunately you are not. So it's as dark as I'm gonna get it. So what you've got here is just a normal incandescent light bulb. You can see very bright, giving off what appears to be white light. It's a little yellowy, but if I put the lenses, the diffraction gradient lenses in front, ooh, look what happens. Isn't that so cool? So we are going to look at other kinds of light with that lens as well. So I'm going to pause and get that one set up. Okay, so what you see here is a gas emission tube and a power supply. So inside the power supply, I have put a glass tube that is filled, in this case, it is hydrogen gas. So I put it in there and make sure we have a connection. What's going to happen is electricity is going to run from one end to the other and excite the electrons in the atoms of hydrogen, and they'll give off a color. So we're going to look first at the color without the glasses on, and then I'll slide the glasses, the diffraction gradient, the prism glasses over top, and you'll be able to see what happens to that color. It gets split into its respective lines. So a pretty kind of purpley reddish color for hydrogen. But now if we look at it with the lens on, notice how, now these are multiples. Remember what happened with the white light? You saw multiple versions. But if you look carefully, you can see a distinct red line. You can see kind of a teal line, and then more difficult to see, there's actually two purple lines. So hydrogen produces an emission spectrum with 4 lines: a red, there's a little better, a red, a blue, and 2 purples. You can see 1 purple real faintly. If it were darker in here, you'd be able to see it better. But there's actually 2 purple lines. So that's hydrogen. That's what it looks like without the glasses. So I'm going to turn this off, and we will switch gases out. I'm going to put helium in there next, and we'll take a look at that. So again, I'll turn it on, and helium gives you kind of like a peachy, yellowy, real pale orange type color. Yep, look how distinct you've got. You've got a red, you've got that very strong orangey yellow color. Oh, but you do have a teal and a purple that you can see. And we're just seeing the very brightest lines. There may be some other ones there that we can't differentiate. This is not the best method in the world, but that's what helium looks like. So then if we do neon, you know what neon looks like, right? Neon signs, bright orange. There it is. There's that bright orange glow. So you can probably, again, predict what are you going to see. Probably a lot of oranges and reds and yellows. And sure enough, if we put the gradient on, probably over to the right is the best version that you're seeing. A lot of yellows and reds and oranges, very little green or blue or purple. If you look off to the right, you can see a lot of the lines, a lot of yellows, a lot of oranges. So not just one yellow line, multiple oranges. That's a good version. Okay, so there's neon for you. If there's a neon sign that's not orange, it's because they've painted the glass, just to let you know. Or they're using a different gas. So neon signs are kind of a generic for glass tubes like this that have a gas inside. It's not all neon. So next I put in xenon. So xenon, look at that pretty blue purple color. So what do you think we're gonna see? Let's find out. So you can see, there we go, some reds, a green, definitely the purple. That's definitely a big bright one. But you can see some reds, kind of like an orangey one, little green one. Okay. And then the last one I'm going to do is mercury. Mercury has a really distinct limey green line. So see if we can see it. So there's mercury. It's glowing what looks like almost white, a little bluish. So you might predict that we have kind of a combination of colors that would produce white. But look at mercury. See that limey green color? So there's a yellow, there's a blue, but that limey green is kind of a very good identifier for mercury. So scientists will actually use emission spectrum in order to identify what gases a certain star contains, because they can use emission spectrum. They can look at it through a prism, just like we're doing, and they can, that was that was much better. You can see them now. So they use the emission spectrum when they look at stars to figure out what kinds of elements are there.